Hello, welcome to this lesson where we're going to look a bit more at how we measure different parts of circles. So we've looked at how to work out the circumference. As a warm-up, can you work out what the circumference of this circle is? Okay, so we've been given the radius is 3 centimeters, so we get circumference is 2 pi times 3, so it's 6 pi, and to 2 decimal places we get 18.85 centimeters. However, we've also got smaller parts of the circumference that we'd like to find sometimes. So here we're looking for the length of the arc, which is this part, the green part on the outside. If we wanted to find this, we can use our circumference rule, and we need to look at the angles, the angle of our arc. So we're using 210 degrees, because it's the angle that our arc takes up. And we also have to remember that the full revolution is 360. Now, all we have to do is make this into a fraction. So we work out what fraction of our full 360 degree circle we have. So we would put 210 over 360, and that would be our angle. So we could go take our circumference rule, and we're going to take the 2 pi r part. So we have 2 pi r, but we're working out, or we're multiplying by the angle here divided by 360. Now, to simplify this, we can take this 2 and divide by the 2 here instead. So you can cancel this and cancel this by 2. So we're going to get pi r equals the angle over just 180. So now we can substitute in our values. We get pi times r, which is our 6 centimeters, times our angle, 210 over 180. And we get 7 pi centimeters, or to 2 decimal places, 22 centimeters. In this question, we're asked to find the length of the arc, and we're going to use the formula that we've just found. So we go length equals pi r times theta over 180. This is called theta, and it's the symbol we often use to represent an angle. We could use x or y, but we just generally use theta. So we substitute our values. Length equals pi r, or 2 times pi, times 120 over 180. So our length is going to become 2 pi times 2 over 3, which is the same as 4 over 3 pi. We could leave it as that, which is the exact form, or we could take it to 2 decimal places, which would be 4.19. And that's it. So can you find the length of this arc? We just use our formula. Length is pi r times theta over 180 degrees. So length is pi times 4 times 290 over 180. This doesn't simplify down nicely, so we'll just go straight to our 2 decimal places, which is 20.24. In this question, could you work out what the equation of a semicircle would be? To do this, you need to work out what angle would go here. Note that a semicircle is just half of a full revolution, so it's just half of what this would be. Have a go at working out what that equation might be. So this value here is 180 degrees because a full revolution is 360 degrees. So our arc length, when it's a semicircle, would be pi times r times 180 degrees, which is our angle, over 180 degrees. Or we could simplify that just to pi r. So this is how we would find the arc length of a semicircle. we're now going to look at how we would calculate the length of a sector. And remember, a sector is just this part, which is our arc, but including these two radii. The two radii, which is a plural of one radius. So, to find the sector length, we have to find the length of the arc, and then the two radius, the length of two radii. So all we have to do is take this, substitute it in, and we're going to get this a bit longer equation. But in reality, it's just finding the arc length and adding two radius to it. Oh, that green thing is our arc. Sorry, our sector. So here we have our sector length formula, and we're just going to have to substitute our values in. So we have length equals pi times our radius, which is 4, times 297 degrees over 180 degrees, plus 2 times our radius, which is 4. We can clean this up a bit, and we'll get 4 pi times 1.65 plus 8. Again, we can clean that up more. We get 6.6 pi plus 8. And this is the exact form. If we wanted to find it in two decimal places, we would get 28.73 centimeters to two decimal places. So can you find the length of this sector? We use our formula length, it's pi r times theta of 180 degrees plus 2r. So we substitute in pi times 3 times 45 degrees over 180 degrees plus 2 times 3. Now you might notice that 45 divided by 180 is a nice fraction. So we end up with 3 pi times a quarter plus 6, 3 over 4 pi plus 6. This is the exact form. And then to two decimal places, we're going to get 8.36. So we're also going to quickly look at the perimeters of compound shapes when we're including circles and parts of circles. So here we've been asked to find the perimeter of this shape. So we have to look at all the different parts we're going to have to find. So here we have our arc, and then one radius of our circle. Now all the radius of our circle are going to be the same, and we've been given this one, so this one's going to be the same length. And then we have the three sides of this square. So we don't need to find this length or add this length to it, but we need to add everything else. So we're going to go perimeter equals, and then we have to find our arc length. So we have pi r times theta over 180. So that's just this green part here. Then we need to add the yellow part. So we have one radius. Then we have to add the three more radius, three sides of the triangle, plus three sides. So we go pi times 3. So we need to be using our knowledge that all of these are the same, and therefore they're all 3 centimeters. So pi times 3 times 45 over 180 plus 3 times 3. Then we can do some work to simplify this one down. We get 3 pi over 4 plus 12. Now this is the exact form, and we can then put it to two decimal places, and we're going to get 14.36. So it's your turn. Can you find the perimeter of this shape? Okay, so perimeter, we're going to have to find this arc here, that arc, plus this side, plus these two, which are the same, and this one again. So we need to find out what the length of the yellow side is. We have this radius here is 5, and the radius is always the same. So we have 5 centimeters here. And we could label this side here as 8 centimeters. So now we just need to find our perimeter all up. So we have our arc. So pi r times theta over 180 plus our radius, 5 centimeters, plus 8 centimeters, and these are the edges of our rectangle. So, okay, pi times 5 times 180 over 180. Now if you remember that this was a semicircle, you could just have forgotten this from the very beginning. And then we're going to add 26. So we end up with 5 pi plus 26 is our exact form. Then we can take it to 2 decimal places, and we're going to get 41.71 centimeters to 2 decimal places. So that's the end of this lesson. This is a summary of what we've covered. I hope it's made sense. If you have any questions, please bring them to me. Thanks.